right. Well, it's good to see everybody. So a couple of announcements real quick. First, anybody interested in retaking last week's inverse trig functions quiz, if you have until next Tuesday, so there's still plenty of time. I'll be here after school today, but there's no morning tutorials because remember, again, tomorrow I have morning duty. But next week, tutorials go back to normal, so you have until the end of tutorials after school on Tuesday. So that also gives you Monday, Tuesday morning, and Tuesday afternoon. We are going to go ahead and talk about a problem on the assignment from yesterday's lesson, trig identities, before we go ahead and get started. But this lesson is actually due on Friday. We'll have a quiz over this material on Monday. And the only other thing, remember on Tuesday we have the what? Got the PSAT, okay. So if you are testing, you want to show up early, make sure you know what room you're in, all that good stuff. But if you are not testing on that day, then basically you've got a late start day. We're going to be going to periods 5 through 8 in the afternoon. So the schedule is posted to the website, but basically from the end of fourth period on, that's what the schedule is. So if you have a lunch, you'll go to a lunch immediately, and I believe your class starts at 12:30. Otherwise, at noon for B lunch, fifth period does start. Okay. Any questions on what's coming up? Okay. Well, let's take a look at number 9. This is how we finished the notes yesterday. We were looking at some co-function and even and odd problems. I just wanted to go ahead and do another one to make sure that we still feel pretty comfortable with it. Number 9 says, if tangent of negative y equals a 0.9, find cotangent of y minus pi over 2. Okay, well, because we're dealing with the cofunction identity, let's start by writing out the actual identity. We got tangent and cotangent. So I'm going to go ahead and say tangent of y is equal to, then we're going to have cotangent of pi over 2 minus y. Remember, the actual identity for cofunction is always, always, always going to be pi over 2 minus your variable. So this is the actual identity. Okay, so let's go ahead and start with what they give me. Tangent of negative y equals 0.9. This is where even and odd comes in. Okay, so if your variable is negative and you're dealing with an even function, that negative can simply vanish. Okay, we can just get rid of it. We don't have to worry about it. If it's an odd function, then that negative gets pulled to the front of your trig function. So the function itself is negative. What kind of function is tangent? Is it even or odd? Ryan, what do you think? Even or odd? It's odd. Okay, so that means this negative, I can pull it to the front. The only two even trig functions we have are cosine and secant. Okay, so this is going to give me that a negative tangent of y is going to equal 0.9. Now remember, these identities, they are equations. So if I want to know the value of tangent of y, I just got to get rid of that negative. So I can multiply through by a -1 or just go ahead and divide through by a -1, whatever you want to do. But I'm getting that tangent of y is a negative 0.9. Okay, so that's the first part here. Okay, questions. Okay, well, now that I know this, where would I go from here? What do I do with that? Maria? Plug it in. Okay, so we just found tangent. Yeah, so let's go ahead and plug it into my identity. That's a negative 0.9 equals cotangent of pi over 2 minus y. And that's a y right there. Okay. So does that mean that negative 0.9 is my answer? Why? What's the problem? See, that's not what they're wanting. They want cotangent of y minus 2. What we have here is cotangent of pi over 2 minus y. So we've got to rewrite this cotangent to make it look like what they want. Okay, so first thing I'm going to do, let's just switch the order of these terms. So a negative 0.9, that's going to equal cotangent. That's going to be a negative y plus pi over 2. All I did was go ahead and switch the order. Okay. So we have y and then pi over 2, but the signs are wrong. What did we do yesterday to fix this? Now multiply by -1. You're on the right track, though. Okay, pretend the -1 is a GCF. Because see, if I multiply through by -1, I'm only going to be able to affect the cotangent, not what's inside of it. So we're going to go ahead, go inside here, and we're going to pretend that that -1 is a greatest common factor. Okay, so -0.9 equals cotangent. So for this binomial, if I divide the -1 out, okay, if I pull it out as a GCF, that's going to give me y minus pi over 2. See, that's what I want. So now, that negative that we've got inside of cotangent, what happens to it? Well, that depends on whether cotangent is even or odd. Remember, if it's even, this -1 just disappears. I don't have to worry about it. If it's odd, I'm going to pull it to the front. Hey, Lane, what is it? It's odd. Okay. It's odd. So that means this negative, I'm going to pull it right out front. So a -0.9 equals a negative cotangent of y minus pi over 2. So if you look, okay, cotangent of y minus pi over 2, cotangent of y minus pi over 2, we've got what they want, but now there's one little detail I got to fix. Okay. See, we got this negative right here. We don't want the negative cotangent, we just want cotangent. So that's an easy fix. Now I'll go ahead and multiply through by a -1. So cotangent of y minus pi over 2, well, that should equal a 0.9. There we go. Okay. The nice thing about problems such as this, numbers 9 through 12, where you're working with the cofunction and the even-odd identities, whatever number you start with, that is either your answer or the answer is the opposite. So at least on these, if you're still a little shaky, you know you got a 50-50 shot. Okay. Because remember what's coming up on Monday. You got a quiz over this material. Yeah, got a quiz. Okay, well, there you go. We'll go ahead and take a look at this again on Friday. So let's look at the paper you picked up on the way in. This is one of my favorite lessons to go ahead and teach. It's a lot of fun. Okay, now here's the thing. These are the only identities that we're going to be responsible for right now. Everything inside this red rectangle. So when it says on your paper sum and difference identities, everything from those down, we're not worried about those yet. Okay? We're going to go ahead and just put them out of our mind. We only need these 5. Reciprocal, quotient, Pythagorean, cofunction, and even odd. So I want to give you a heads up, okay? Over the next 2 days, it's either going to be tomorrow or it's going to be on Friday. One of those 2 days, when you walk in, at the very first of class, I'm going to tell you, take out a sheet of paper, okay? And then I'm going to have you write down some identities for me. But every class is going to be different. I'm going to go ahead and give you a combination. I might go ahead and say, give me all the Pythagorean identities and the even-odd identities. Okay. Or another class, I might say, give me the reciprocal identities and all the cofunction identities. Okay, so it's going to be for a grade. So there's no math involved, and we're at the beginning of the 9 weeks, so I'm hoping this is going to be a really, really easy 100 for everybody. Okay, all you got to do is have these memorized. Okay, so you do have to have those memorized. All right, so any questions about that? Hey, it's either tomorrow or Friday. So if you walk in tomorrow and I don't say, hey, pull out a sheet of paper or something like that, guaranteed it's Friday. One of those 2 days, I want to get another grade this week. Okay. I think you've already got these memorized, right? Oh, that's okay. No, we just finished up the notes from Friday. I did give out the homework, though. Did I give the homework Friday or yesterday? Yesterday. Okay. So, okay. Well, let's go ahead and take a look at our lesson now, simplifying trigonometric expressions. To simplify a trig expression means to rewrite it as a numerical expression or in terms of a single trig function. Identities are useful in simplifying trig expressions. So here's the thing. We're going to be using a combination of those identities we were just looking at, as well as different algebraic strategies to rewrite these. You're going to be given an expression, and we want to simplify it as much as possible. Okay, we want to get it down. In this case, on this first page right here, every single one of these is going to simplify down to just a single monomial term. Okay, but there's going to be a lot of different ways for us to get there. Okay, here are some strategies listed for you. We could rewrite using any of the identities. Here it says reciprocal and quotient. Then it moves on to say Pythagorean. Okay, so any of the identities can be used here. Yeah. You need the homework too? Okay. Now, I would recommend for this lesson, as we go through these notes, probably a really good idea, make sure that your identity list is out on your desk so you can just refer to that pretty easily. Because the more of these you recognize, the easier these problems are going to be for you. Okay, so you can use any of the identities that we're looking at. Combine fractions using a common denominator, break fractions apart. You could use algebraic techniques. So we will be coming up with common denominators. Maybe you'll be distributing across a group. There's all kinds of things that we could do. Factoring is also another option. You could use something as simple as a GCF, or maybe you'll recognize the difference of squares. Okay, all of these different techniques with the identities, we're going to be using these together. Now, I was really surprised when I first saw this resource. This is probably, I think, the best strategy, especially for students who are just starting this. If you hit a brick wall, if you're not sure what to do, okay, here's.
Is this going to be on the quiz on Monday?
No, this will be on a quiz next Thursday. So we're actually going to have 2 quizzes next week. So if you're starting, if you don't see anything you can do algebraically, if you're not recognizing any identities, rewrite every trig function in terms of sine and cosine. That is a great way to start these problems. In fact, that's what we're going to go ahead and do for the first couple. All right, so here we go. Number 1, secant of theta minus sine of theta times tangent of theta. Now, we have to use the identities. What's the reciprocal of secant? Cosine. Now, I can't just replace it with cosine. Remember, I got to use an identity. So secant, I'm going to rewrite that as 1 over cosine theta. Minus, well, sine, I'm going to leave alone. We're going to write everything in terms of sine and cosine. Now, tangent, we have a quotient identity. How can I rewrite tangent? Sine over cosine. There we go. So sine of theta over cosine of theta. Okay. Well, by doing this, this allows me to do something algebraically. I can actually multiply sine times sine over cosine. Just pretend this sine is over 1 and multiply straight across. So 1 over cosine of theta minus, what's a sine times sine? What do you think that would be? Not 2 sine, you're close. Sine squared. So sine squared of theta. And one thing I want to say about this, it's the trig function that'll carry your power, not the variable. Okay, so it'll be sine squared of theta, not sine theta squared. That won't happen. And then, of course, we have this over cosine. Well, what do we notice now that I did that? We got 2 fractions, but they have a what? They got a common denominator. So I can just go ahead and combine these. So I got everything over cosine of theta. So up top, I'm going to have the 1 minus sine squared of theta. Now, one thing about the Pythagorean identities, you can only use a Pythagorean if there's a square. So if there's no square, don't worry about the Pythagoreans. But when I multiplied these together, that's where I introduced this square from, okay? So for 1 minus sine squared, I want to know, is there something I can do with that? All right. Well, let's look at the Pythagorean identity that involves sine squared. Remember, it says cosine squared of theta plus sine squared of theta is equal to 1. So it's not the identity itself. I want to rewrite this identity so that one side of it is 1 minus sine squared. So it looks like exactly what I have in my expression. Okay? because then I can use substitution. Well, if I go ahead and subtract sine squared over, 1 minus sine squared, okay, what's left on the other side? That'd be cosine squared. So see, even though I manipulated the original identity, this is another true identity. That's a true statement right there. So you notice I got 1 minus sine squared. I got 1 minus sine squared. Well, what does 1 minus sine squared equal? See, I can take this binomial and I can just replace it with that cosine squared. So cosine squared of theta over cosine theta. So is everybody okay with how I went from here to here? I used substitution. The fact that 1 minus sine squared equals cosine squared, so I just replaced it. Okay. Well, you notice anything about this last fraction? How many cosines do I have up top? Yeah, 2 because it's squared. You know, if it helps, I could rewrite it. I could say cosine of theta times cosine of theta over cosine of theta. That might make it a little easier to see. I can cancel out a pair of cosines. There's my answer. So secant theta minus sine theta tangent theta, this is going to equal cosine of theta. That's what we want to do with these problems. We want to simplify these expressions as much as we can. We're going to use algebra and we're going to use the identities. Okay. Here's what's going to trip a lot of people up. Okay. This is how we did it step by step. Is that the only way I could have gotten to the answer? You're going to find there's going to be multiple ways to get from your problem to your answer. Okay? And there's really no trick to it. As long as your algebra is correct and you're using those identities, you're always going to be able to get to where you need to. So sometimes it might only take you a few steps. Sometimes it might take you 6 or 7. Okay? It depends on what path you choose. Okay? All right, let's try another one of these. Let's try another one. Okay. And I won't go ahead and start showing you multiple ways until we get to number 3. Right now, we're just kind of talking about it. Okay. So I've got sine of A plus cosine of A times tangent of A. Okay. Well, there's nothing I can do algebraically. There's no GCF. So let's do like we did in number 1. Let's rewrite everything using sine and cosine. Okay. So this sine of A, I'm going to leave it alone. Plus cosine of A, I'm going to leave it alone. Okay. Well, what would tangent of A be? Yeah, sine of A over cosine of A. As soon as I rewrite it, what do you see that I can do? I can simplify. See, pretend this cosine of A is over 1. I've got a cosine in the numerator and denominator. Those are going to cancel. Okay. So what I'm left with is sine of A plus sine of A. Okay. Now, if you think about the trig function as a variable, a lot of these rules are going to come a lot easier. Like if I said x plus x, you would tell me 2x. So what's sine of A plus sine of A? 2 sine of A. That's what our goal is in this lesson. We want to take some expression and we want to simplify it as much as we possibly can. Okay, we're using algebra, we're using the identities. Okay. How are we doing? Does anybody have any questions so far? And would that be the only way to go from the binomial to 2 sine of A? Nope, there's going to be a lot of other ways to do it. Okay, so with number 3, this is the first one I'm going to show you at least a couple of ways. I'm going to do the same thing on number 4. Okay, so this strategy seems to be working pretty well for us. Let's go ahead and keep it going. Okay, cotangent squared minus cosecant squared Let's rewrite everything in terms of sine and cosine. Now, for a quotient identity, we already know that cotangent of u would equal cosine over sine. Okay, so what would cotangent squared equal? Say again? True, but in terms of the quotient identity. There you go. The power would just follow through the identity. So if cotangent is cosine over sine, well then cotangent squared would be cosine squared over sine squared minus, okay, well now we can use a reciprocal identity. I know that cosecant is going to be 1 over sine. So what's cosecant squared? 1 over sine squared. Okay. Now this one, again, was pretty nice to us. Right, Reed? Okay. Came up with common denominator. So let's go ahead and pull those together. All right. Let's see what we got. Everything's going to be over sine squared of u. But up top, I'm going to have cosine squared of u minus 1. Is everybody with me so far? Okay. Well, what part do you think I want to focus on now, the numerator or the denominator? I focus on the numerator. I'd probably be now looking at Pythagorean identities. Okay, so the Pythagorean that contains cosine squared, remember it looks like this. Cosine squared of u plus sine squared of u is equal to 1. So what I want to do is make one side of this equation look like cosine squared minus 1. Okay, so let's go ahead and subtract the 1 over. So cosine squared of u minus 1 plus sine squared of u is equal to 0. So see, I've got what I want, but what do I not need? Okay, that's sine squared. So how am I going to get it to the other side? Yeah, I'm going to subtract it. I'm just rewriting this equation, just like you'd solve any other. So cosine squared of u minus 1 equals negative sine squared of u. Now I can use substitution. Okay. See, I went ahead and rewrote this so that one side is cosine squared u minus 1. That's exactly what I've got in my numerator. So I'm just going to replace it. I know that that equals negative sine of u. Okay. So negative sine squared of u over sine squared of u. Okay. Well, what's anything divided by its opposite? Audrey? 1, you're very close. Oh, no, you were closer the first time. One's positive, one's negative. So what kind of 1? Negative 1. So that whole binomial up there actually equals negative 1. Now, only 2 people throughout the entire day have noticed this so far. Maybe somebody in here knows what I'm talking about. So that's my answer. We simplified that down to negative 1. Let me show you how we get this in one step. Okay. Does this look familiar? That's one of what type of identity? That's one of my Pythagorean identities. Okay. Well, why don't I go ahead and rewrite it so that one side is cotangent squared minus cosecant squared. So if I subtract this over, cotangent squared of u minus cosecant squared of u, well, let's go ahead and subtract the 1 over at the same time. Here's your answer. See, it really depends on what you notice. So I'm hoping now, remember I said The more you have to have these memorized, it's going to make these lessons a lot easier. Okay, if you don't, you're going to struggle. If you can recognize these identities, you're going to be able to go through these a lot quicker. Okay, see, I was able to do it in one step as compared to the rest. And that's only 2 ways. Would there be more? There's so many ways to work these problems. I mean, that's the thing. That's what always catches people when we first start this lesson, because in other concepts, you have an example, you do it step by step, you can kind of use that as a model, right, to help you with your other problems. You really can't do that here, because every problem you could solve a different way. Odds are people are going to see different things and they're going to come to different outcomes. Okay, so I know what you're thinking. Mr. West, I got this. I'm ready for one on my own. Okay, try this one. Okay, now you've already got a couple of options. We know that rewriting everything in terms of sine and cosine works. You can go ahead and do that. Okay, or you'll notice you can do something algebraically without even doing any identities first. What am I referring to? How would I drop the parentheses? You could distribute. Yeah. Okay. So I'm going to go ahead, give you a couple of minutes. You will get this down to a single term, a monomial. Okay. If you want to kind of check with those around you, or if you want to raise your hand, I'll come around and tell you if you're correct or not. Sine of x times tangent of x plus cotangent x divided by cosine of x. I really like these types of problems because they're almost like little puzzles. Like, what can I do to keep the problem going? Let's see. Wednesday, 2:20. Okay, we got plenty of time. 30 seconds. All right, that's 2 minutes. Did anybody want me to check your answer before I write it on the board? Okay, okay. So here is what you should be getting. This whole quotient should equal secant squared of x. How many people got that? Why didn't y'all raise your hand? Gotta be confident. Be confident. Okay. Even if you're wrong, I'm up here. I'm wrong all the time. Doesn't matter. Okay. So let me show you what I did first, and then we'll go ahead and find another way to do it. Okay. So because we had sine times this group, I went ahead and just took sine over cosine. I rewrote it like this. I said sine of x over cosine of x times tangent of x plus cotangent of x. Okay. Well, here I didn't rewrite everything in terms of sine and cosine. What is sine over cosine? Isn't that tangent? Okay. So I reversed that. I said this is tangent times tangent plus cotangent. Okay. Well, let's go ahead and distribute. What's a tangent times tangent? Okay. Really? What is it? Tangent squared. tangent times cotangent, that's 1. Okay. Remember, what's the relationship between tangent and cotangent? They're reciprocals. So if I were to take tangent times cotangent, I could take the reciprocal of 1, like maybe tangent times 1 over tangent. Okay. Those cancel. There you go. So when you multiply reciprocals, you get 1. So sine times cosecant would be 1. Cosine times secant would be 1. Okay. Well, does that look familiar? Tangent squared of x plus 1, if you look at your sheet, that's one of your 3 Pythagorean identities. What is tangent squared of x plus 1 equal? Secant squared of x. Did anybody happen to solve it like I did? Okay. So how many people rewrote everything in terms of sine and cosine? Okay. So let's try that. All right. Okay. So I've got sine outside. Okay, well, tangent is sine over cosine. Then I'm going to add cotangent is cosine over sine. And remember, that's just the numerator. All of this is still over cosine of x. Okay. So I'm guessing after you did this, you probably distributed. Okay. So if I distribute sine to the first one, that's going to be sine squared of x over cosine. Plus, what's sine times this fraction? Just cosine. Those signs are going to cancel. So I got plus cosine of x, and then this is all over cosine of x. Now I can do one of 2 things here. I can either continue to focus on the numerator, I can combine both of these into a single term, or I could go ahead and pretend that this cosine down below is a fraction multiplied by its reciprocal. Okay. So I'm going to take this opportunity. I'm going to go ahead, let's find a common denominator. Let's continue with the numerator. So let's put this over 1. Okay. Anybody think they know what is a common denominator between cosine and 1? Well, 1 is a factor, but what's the one thing they'll both evenly divide into? Cosine. Okay. Think about like what you would do with numerical values. Let me give you an example. If you had something like, oh, I don't know, 2/3 plus 5/6, okay, your common denominator would be 6, right? So you've got to change one of the fractions so that it has that. So you multiply by a version of 1 to give you what you need. We're going to do the same thing here. I need my common denominator to be cosine. So I'm going to multiply this one by cosine over cosine. Okay. So this is going to be sine squared of x over cosine of x, plus, when I multiply those, cosine squared of x over cosine of x. Remember, this is all still over cosine of x. So you can actually create a common denominator if you need to. Right, Nia? Right. Okay. So let's go ahead and pull these together. So up top, okay, I've got sine squared of x plus cosine squared of x over cosine of x. And remember, all that's still over cosine of x. Okay. Anybody notice it? Anything look familiar from your sheet? What's sine squared plus cosine squared? 1. That's one of your Pythagorean identities. So I can say 1 over cosine of x divided by cosine of x. Well, now we can do what I said a moment ago. Let's pretend that's 1, and let's flip it. So this is going to be 1 over cosine times 1 over cosine. Well, that's 1 over cosine squared. But what's 1 over cosine squared? Secant squared. And some ways will be prettier than others. Okay. But the more of these problems you work and you practice, you're going to get to the point where you're like, okay, I'm going to do this, but then you're going to realize if I do this, I'm going to have to do A, B, C, and D. I don't want to do all that work. So let's try to think of another way. Okay. So this way was definitely a lot longer than what we just did. Okay. So at this point, is this starting to make sense? Like what the big picture is, what our goal here is. Does anybody have any questions? Okay. Well, here's how we're going to end today. You folks are going to walk me through a problem. Number 5. And I'll even do this. Okay. I'll go ahead and tell you that number 5, cosecant minus cotangent squared over cosecant, this should simplify down to just sine. Okay. So here's the starting line. Here's the finish line. All I got to do is go find the path. Okay. What would you like me to do? You folks tell me. And remember, as long as your algebra is correct and you're following those rules, those identities, might take you a little longer, might be short, but you should always be able to get to the finish line, your answer. Okay, so somebody give me an idea. Anything. Naya, what you got? Oh, so you want me to put cosecant over 1 and get a common denominator? Let's do that. Okay. You're only the second person today to do that. Every other class besides one individual said, let's rewrite everything in terms of sine and cosine. So that's good. That's good. So I'm going to put this over 1. Okay. So what do you think is a common denominator between 1 and cosecant? I'll be cosecant. Okay. So just like we did before, I'm going to multiply both the numerator and denominator by that cosecant. Okay, so this is what it's going to give me. Cosecant squared over cosecant theta. Then I got minus cotangent squared of theta over cosecant of theta. Okay, so I created a common denominator. I can go ahead and pull these together. Okay. So this is now going to be cosecant squared minus cotangent squared all over cosecant. Now what? You're very close. It's not -1. What would it be? Ooh, not -1. +1. Let's see why. Okay. So he's referring to a Pythagorean identity for the numerator. The identity says cotangent squared of theta plus 1 equals cosecant squared of theta. So if I want to make one side look like that numerator, all I got to do is subtract cotangent squared. So see, now I got the cosecant squared of theta minus cotangent squared of theta. But the only thing left is 1. Okay. I can replace this numerator right here with 1. Okay. Well, let's see here. If that's 1 over cosecant of theta, what's 1 over cosecant? That's sine, your reciprocal identity. There you go. Okay. How are we doing? Okay. All right. So here's what I'd like you to do ahead of time for tomorrow. Try number 6. Okay, we'll start with number 6 tomorrow. It says cosecant beta minus sine beta over cosecant of beta. This will also simplify to a single monomial. Now, I don't want you to think that, and this lesson really doesn't do a lot to help you with that. They won't always simplify down to a single term like we've seen here. It might be a binomial. Maybe the simplest term would still be a fraction. Yes, the majority of the time, you're probably going to be able to get it down to a single trig function. Okay. But that's not absolute. All right. So if before you take off, I mean, you've still got yourself about 6 minutes. If you want to try to get that done before you leave, I can tell you whether or not you got it correct. Okay. So let me go ahead and erase this and get set up for the next class. We are good to go. Okay. Okay. Clear sky.